Hi there, and welcome to today's lesson on relative density. So, for those of you that do not know, I am currently a 5th grade teacher, and I teach science. And one of the things that we go over every year is relative density. It's a skill that students really need to understand, and it's one of the trickier skills that if it doesn't click right away, it can get lost in all of the things that students need to learn. So today, I'd like to spend some time and really cover what it is, what it looks like, and how you can know how to answer a question about relative density. So I'm going to split this video into 2 segments. First, we'll start together and we'll look at what relative density is on paper. I'll explain some terms that you would need to know. And then second, we'll look at relative density in practice. I will flip my camera around here and we'll look at some relative density experiments, some things that you might expect to see on some kind of test maybe in the future. All right, so to start, what is density? Density is the amount of matter inside an object compared to its volume. So to think of that, small things with big mass, so small things that are really heavy, like a metal ball, have a lot of density. They're really dense. Whereas the opposite of that, big things with a little bit of mass, think like a styrofoam packing peanut or something like that, have low density. And so when we're talking relative density, we're going to be talking what is that item's density compared to water. So in my fantastic cup here, I always have to tell my students that I'm not an artist, but I'm a science teacher, so this is what they get to work with. So in our cup, if we were to fill it with some pink water, which is the only color I have today, what would happen if I put some stuff into it? So let's start with everyone's favorite easy example. What are some things we know? Wood. What happens when you put wood in water? Most people know this, but it floats. It floats. I'll just put an F there. Now what happens, let's say, if I put a glass marble in water? Well, you throw that glass marble into the water and it sinks right down to the bottom all the way. Marbles sink. I'll give that a little S there for sinks. And that's really all relative density is does it float on water or does it sink? Now this is where people get confused, is that this not only applies to solid things like a piece of wood or a marble, but also liquids. And those are harder to tell because we don't see a lot of liquids that we don't mix a lot of liquids with water in our everyday life. Whereas solids are a little bit easier to kind of intuitively guess. So when we go to our next segment of the video, we will look at how some liquids interact with water and we can find their relative density. Stick around. All right, so here we are for the second half of our video, and what we have is just a clear glass of water, nothing exciting there. What I'm going to do is I'm going to add some liquids into it, and we're going to talk about whether or not they are less dense than water or more dense than water based on how they behave when they are poured in. So I'm going to try and keep them a mystery, and I will reveal them at the end and see if you can guess what they are. So our first one is going to be a nice sweet item, golden in color. Maybe you can guess what it is already, but you can see as it's drizzling in, it is sinking all the way down to the bottom. I'll do a little bit more here, get a nice layer at the bottom for us. And you can see we have a nice golden layer down there at the bottom. So if it sinks down at the bottom of the water, then we know that it is more dense than water. So if we're talking in terms of relative density, we say that mystery liquid number 1 is more dense than water. Mystery liquid number 2 is also a golden color. Try and keep it out of the frame as I pour from very high up, not make a mess. Ooh. That didn't quite stay out of frame, but that's okay. It's in a mystery cup. We can see this one is a little bit more yellow. It poured down through the water and then rose back up to the top. And because of that, we know that it is less dense than water. And we have these nice, pretty layers. So we have layer 1 at the top, layer 2, which is our water right in the middle, and then layer 3 down at the bottom. What I thought would be fun is to test a few little knickknacks I had laying around my house and see kind of where they fell in our density layers. So the first one I have is a plastic piping tool. So we'll toss it in and see if it is more dense than water, less dense than water, or maybe more or less dense than another liquid. So let's see, here we go. Piping plastic. Ooh, look at that. I'll give it a little poke. All right, and we can see that that is kind of floating on top of the water. So we could say that that's less dense than water, but maybe more dense than our first mystery liquid. And then our last one is a glass seashell. We'll pop this one in, see where it lands. There it goes, all the way down and resting on top of that bottom layer. So we're floating here, but more dense than water, but not more dense than this liquid. All right, so if you were a keen observer, you might have noticed that our first liquid is honey. Some tasty honey, I love it. And our second liquid is oil. Hopefully this gives you some ideas on how relative density works. I hope this video has helped you become a little bit better with science and feel a little bit more comfortable in class. So thank you all for listening. I hope to see you all very, very soon.